So, hello and welcome to the USV-Lir Microbit Sensor Pod Abstraction project. My name is Adam O'Brien, and my student number is 2009-3460, and my stream is Internet of Things. So, the key goals of the project were to create a microbit interface for the USV-Lir, seen in the left here, and we have a startup, movement, sensor deploy, and auto movement make blocks for the USV-Lir now. Another goal was to create a sensor pod that can take measurements of the water autonomously. So we essentially built a state machine sensor pod that takes in data when it's submerged and transmits data when it's resubmerged. There's also an app interface to go along with this project, so you can hit a button on your phone that will say sensor deploy, and you can deploy a sensor remotely from your phone anywhere in the world. And to wrap everything up, the ease of use with the Microbit library makes it so that any user, regardless of their technical background, can do their own mission on the USV-Lir. So with that being said, we'll dive into a code explanation. The code has been hosted on GitHub for the duration of the semester, so all changes can be seen there, and the current working code can be seen in USV and usv.typescript. So we can see our make blocks here. So we have our startup, we have our movement make blocks, our auto drive, and our deploy. So first of all, here's what the Microbit library actually looks like, along with a listen for sensor pod, pH, and other metrics. Here's the code for the USV itself. So we have a timer counter and the USV mode, and we also write digital pins to the sensor deployment mechanism. This makes it so when the USV goes into microbit mode, nothing will deploy until you tell it to. The forever counter here makes it so if the timer goes over 5, the USV's motors will turn off. Then we have our radio received. So if a number is sent, that's either 0 or 1, it'll change the mode from manual to autonomous. Then we have our receive string for our sensor deploy. So if we receive an up, the sensor deploy will go up, down for down, and stop for stop. Then we have the radio receive for motor control. So this checks what mode the USV is in, and if it's in manual drive mode, it'll give access to the right and left motors, and if it's in autonomous mode, it'll go and do some calculations to find out where the shortest path is, and it'll correct the course according to the degree difference from the microbit compass. Then we have the helper functions here, so that's the calculation for the shortest path, and that's the code for adjusting the course. So then we have the actual cloud side of things. So this is the Microbit cloud board code. We have a lot of functions here for different things. We have one for parsing JSON messages, taking the value from the JSON messages or the names, serial printing to the MQTT messages, sending IFTTT notifications. So for example, if topic 1 receives a message, there'll be a sensor deploy done for 1 second down and 1 second up, and it'll send a notification as to what values were gathered from the sensor deploy. Then for topic 2, we have a slider on the app that moves the motors depending on where you slide them. Then we have the radio received, which listens for the sensor pod sending out its values, and it saves them to variables to be used later. They're used in the IFTTT notification, so when they are received, they'll be sent off in a notification. Then we have the sensor pod code itself. So we have radio group 73 for all USV devices. We have submerge set to 1 by default, so it just takes in values and adds them to an array list. Then if it's unsubmerged, it sends them back over the radio and it removes the value from the list to make sure that there's no duplicates. And then we have a radio received that listens for the same command as the deploy. So based on the deploy state, the sensor pod will know if it's submerged or not. Then we have our Bbot dashboard setup. So here we have the actual architecture of the system. So the way it works is that we have a radio controller for user input that will speak to a radio receiver, and depending on what message is received, it will change the state of the multiplexer. So if a switch is hit that changes the USV into microbit mode, all of the input from the microbit itself will be taken to the output of the MUX, which will then drive the motors and the sensor deployment mechanism. So when the microbit mode is enabled, the USV onboard.typescript is loaded onto the USV's microbit. So this tells the sensor pod when it is submerged, and when the sensor pod is resubmerged, it sends values back to the cloud board, so it goes up to the MQTT broker Bbot and back down to the app interface. Then, when the switch is in the Pixhawk mode, we can receive telemetry signals from a laptop to tell the Pixhawk which motors to drive to get to its destination. It uses the GPS to keep track of its destination, and it's powered by the battery itself coming off of this module here. And when the switch is in its final state, it gives the user access from the remote control itself. So the triggers on the remote can be moved to move the motors, and different switches can be flipped to change the state of the sensor deployment mechanism. And now that we've covered all of the code side of things, I'll play a short video showing the work done over the semester, followed by demos of the different aspects of the project. So welcome to the actual sensor pod itself. On the inside of this enclosure you can see that there's a printed circuit board, and on top of that there's a breadboard adapter for the microbit. So that can take all of the pins on the microbit and bring it to different sensors like the temperature and pH. There's also a local display on the back to show what temperature and pH is currently inside. So if I take a high pH of 10 and I put it underneath, you can see it changing. So it'll get about to 9, it'll be 1 or 2 points off. And then we can do an actual deploy through the MQTT app. So if I press deploy, we'll hear some relays moving, and that'll indicate the sensor deployment winch moving down. And then we'll have incoming sensor data on a line graph and on the gauges. And go. So welcome to the auto drive demo of the USV. So the way it works is we have a bandwidth between 30 and minus 30, and if that's the case, the USV will go forward. That's the degree difference between the direction the user gives and the direction the USV is actually facing. So if it goes outside of those, it'll adjust the left and right motor. So here we have the compass microbit changing direction, and we can see it coming up here. that's calculating our degree difference. So at the moment we have a degree difference of around 1 to 30. It's around 1 now. So if we turn on the USV and we turn on our controller, we can put it into auto drive mode and go north. So right now it's going with both motors because it's in between 30, but if we put that out of direction, it'll only do the left motor. And then the same for the right motor. Then we can change direction as well to east. And we can change the east direction to go forward. And then the same with south and west.